Please go ahead, pause the video, and try this warm-up problem. So hopefully this is what you got when you were graphing. So answering all those questions, we know because it's a cubic and it's an even or a positive number in front, we're falling to the left, rising to the right. I solved for the zeros. I saw that I had one of them as a multiplicity of 2, so it touches and turns. One of them is a multiplicity of 1, so it's crossing through. I know that I have at most 2 turning points, and I threw in a couple more points just to get a more accurate looking graph. And there's my graph. So today we're going to continue looking at dividing polynomials, remainder theorem, and factor theorem. Specifically today, though, we're going to use the factor theorem to solve a polynomial equation. So the factor theorem, it says let f of x be a polynomial. If f of c equals 0, then x minus c is a factor of f of x. And then vice versa. If x minus c is a factor of f of x, then f of c equals 0. So kind of talking about in yesterday's lesson with the remainder theorem, remember like f of c equals a number, that number is the remainder. So essentially here it's saying that if my remainder is 0, then we have what we considered then a factor, where I could technically start factoring the polynomial, where then each thing I set equal to 0, and that becomes then the 0 of the polynomial. So let's take a look at an example. It says we're going to use synthetic division to divide f of x equals 2x cubed minus 9x squared minus 32x minus 21 by x minus 7. And we're going to use these results to find all zeros of f of x. So remember, when I give you this x minus 7, that's why it's a linear. That's why we can use synthetic division. It's always x minus c. So in this case, our c value is the opposite sign. So c is 7, and 7 is the number that I want to use when I'm starting my synthetic division setup. If I look at my terms in my dividend, I don't have any missing terms, so I don't have to throw in any zeros. And so my coefficients are 2, -9, -32, and -21. All right, so starting our synthetic division, I'm going to bring down that lead coefficient. We'll multiply. 2 times 7 is 14, and I'm going to add -9 plus 14 is 5. Repeat the process. 5 times 7 is 35. Add up the column, and I get positive 3. 3 times 7 is 21. Add up that column, I get 0. So there's no more to add on because all the columns have been filled. Notice that this last number here is always the remainder. And so based off of this definition that we just talked about, I want a remainder of 0. So that means that x minus 7 is going to be a factor. So the fact that we're talking about an x to the third tells us that we should be finding 3 different zeros or 3 different solutions, okay? So we should have 3 solutions / zeros. And so since the problem says use the results to find all zeros of f, well, I know that one of my answers is 7, because 7 was the number that we got where we had a remainder of 0. So now I have to figure out what the other 2 zeros are, and we're going to use the numbers that create our quotient in order to do that. So remember, I'm going to write this then as a polynomial 1 degree less than what we started with. So this is going to turn into this 2x squared plus 5x plus 3. Now, to find the zeros means that I want to solve for x, so I want to set this equal to 0. Because we are solving a quadratic, remember back in chapter 1, we talked about there's 4 ways to solve. You can factor, square root, complete the square, or quadratic formula. I would suggest that we try to factor. The nice thing about this is that the lead coefficient, because there is no GCF here, the lead coefficient is prime, so there's only one way to multiply to 2. That's 1 times 2. And then the last number is very easy to see. That's a prime number as well, so that's 1 times 3. So when I'm creating my 2 binomials, I know that I'm going to start with a 2x and a 1x. I know that I'm going to have a 1 and a 3 to finish it off. Everything's positive, so everything will stay positive. So then how am I going to get that middle term of 5x? Well, I'm going to guess if I put the 3 here and the 1 there, notice that I can always check by multiplying the inside and outside terms and making sure it adds up to that middle term of 5x. So the outside terms, 2x times 1 multiplied to 2x. Inside terms, 3 times x is 3x. Notice that if I was to add those, I am going to get 5x. So that means that we factored correctly. And so now I can set each of those factors equal to 0 to finish the rest of my problem. So I'm going to subtract 3 from both sides. That gives me 2x equal -3. I'll divide everything by 2. And so another 0 is -3/2. Over here, all I have to do to get x by itself is subtract 1. And so -1 is my third and final 0. So once again, polynomial is degree 3, so I should have 3 zeros. We were able to see that we're dividing by a factor that gave us that remainder of 0, which allowed us to continue solving. Okay, let's take a look at another example. It's worded a little differently, but it is still the same idea. So it says solve the equation 15x cubed plus 14x squared minus 3x minus 2 equals 0, given that -1 is a 0 of f of x equals 15x to the third plus 14x squared minus 3x minus 2. All right, so once again, if they're wanting us to solve, they're wanting us to find the zeros. In this problem, I'm talking about degree 3, so there are going to be 3 zeros. And in this problem, the way that they have it worded, it says that it's given that -1 is a 0. So they're already giving me an answer. One of my 3 answers is -1. And so because that is my number, I'm not changing the signs like we did in the last problem. Because they didn't give us a binomial that's being divided, they gave me the legit 0. So -1 gets to go on the outside. And if I'm looking at my dividend, I don't see that there are any missing terms. So that means that we'll have 15, 14, -3, and -2. And you'll know that you made a mistake if you change the sign. If you don't get 0 for your remainder, you know you made a mistake, okay? Because if it's telling us that it equals 0 and I'm giving you a 0, if you don't get 0 for your remainder, you know you made a mistake somewhere. So bring down that lead coefficient of 15. 15 times -1 is -15. Add that up, we get -1. -1 times -1 is +1. Add that up, we get -2. -2 times -1 is +2. Add that up, you get 0, which is what we wanted. We wanted a remainder of 0. So that means that I get to rewrite this as 1 degree less. So it becomes 15x squared minus 1x minus 2. This equals 0. I need to finish solving for my 2 other zeros. Okay, so I am going to factor 15 is either 1 times 15 or 3 times 5. So those are going to be the numbers that are going to start my factors. Nice thing about 2 is that it's just 1 times 2. Because I want to get a -1 in the middle, I'm probably going to want to start with numbers that are closer to each other. So I'm going to start with the 3 and the 5 when I'm trying to factor. So I'm going to have a 3x and I'm going to have a 5x. I know that one of those spaces has to be a 1 and one of those spaces has to be a 2. Because I need to multiply to a -2, I'm going to need one of each sign as well. So this is where the guessing comes into play. I don't know which one's negative. I don't know where the 1 or where the 2 goes. So it's going to maybe be trial and error. I'm going to try 1 being positive first, -2 being negative second. Okay, so then I'm going to guess. Now I'm going to check to make sure. Hopefully this gets me -1 in the middle. So 3x times -2 is -6x. And 5 times 1 is going to give me that 5x. And notice that, hey, yes, that does add up to -1. So I guessed correctly. So that means that 3x plus 1 has to equal 0. And 5x minus 2 has to equal 0. And those are going to give me my other 2 zeros. So I'm going to subtract 1 from both sides. That gives me 3x to be -1. I'll divide by 3. So it looks like -1/3 is our second zero. I'm going to add 2 to both sides and then divide by 5. So it looks like 2/5 is my third and final zero. So here are my 3 answers because we started with degree 3. And once again, they gave us one of the zeros, so we were just finding the other 2. Okay, let's take a look at another one. So it's worded just like the last problem. So I'm giving you the zero. So it says, given that -3/2 is the zero. So I know that that's one of my answers. And that also means that I don't have to change the sign. It's going to stay -3/2. So now when I'm setting up my synthetic division, I see that I go from a cube to a square to 1 to no exponent. So that means that there are no missing terms, so I don't have to throw in any zeros. So I'm putting my lead numbers there. All right, I'm going to bring down the 2, and now I'm going to multiply. So a couple different ways for you to think about this. I mean, you obviously have a calculator, so feel free to use that. I'm going to multiply 2 by the numerator, so it's going to be 2 times -3, and then I'm going to divide by 2. So 2 times -3 is -6, and -6 divided by 2 is going to give me -3. And then when I add that up, I get 0. Repeat the process. Well, this time, 0 times anything is going to be 0. Add that up, I get -8. Repeat the process. I'm going to multiply -8 times -3. So negative times a negative, that's going to give me +24. And then I'm going to divide by 2, and that's going to give me +12. Add that up, we get 0. And remember, if I don't get 0 for the last term, we know we made a mistake, especially since we were given the 0. All right, so this means that writing my polynomial 1 degree less than what we started with, it's going to be 2x squared. There is no x, so I don't have to put plus 0x, so then it's just -8. So if I want to solve, that means I need to set this equal to 0. So when we're talking about solving this quadratic, there are a couple different ways we can go about this. We could try to factor. This also doesn't contain an x, so it might be fastest if we just do the square root method. So square root method means that I want to isolate that squared term. So I'm going to add the 8, and then I'm going to divide by 2. So x squared equals 4, and then to get rid of a square, I take the square root, but I don't want to forget that I have 2 solutions. So I'll have a +2 as well as a -2. And there are my 3 zeros because we're talking degree 3 of our original polynomial. So that's why I should have 3 answers. All right, I would suggest that you pause the video and try this checkpoint problem. Okay, so remember, don't change the sign because they gave us the 0. Doing synthetic division, we got our remainder of 0, which is what we should have. I then have x squared minus 3x minus 10, which I could definitely factor to get my other 2 zeros, 3 zeros in total because we have degree 3. So 5, -2, and 8. So that's us using the factor theorem to solve polynomial equations.